Today we're looking at notes KK-2 rationals, alternative shapes. So on each problem find, like before, roots, VA, HA, y-intercept, and then graph. So first thing we're going to do is try and factor number 1. So on number 1, in the numerator, definitely factors, it's a difference of squares. So x plus 3, x minus 3. And then the denominator, similar, it's a difference of squares. This would be x plus 2, x minus 2. Okay, so now I have no holes, right? Because none of my factors will cancel with each other. All right. Now I'm going to go to town. Roots. So remember, roots is when the numerator equals 0. So the numerator equals 0, that would be x plus 3 equals 0, as well as x minus 3 equals 0. So x is going to equal negative 3 and x is going to equal positive 3. So my roots are negative 3, 0 and positive 3, 0. Okay, my VA, remember, is denominator equal to 0. So x plus 2 equals 0, x minus 2, x minus 2 equals 0. So x equals negative 2. And x equals positive 2. So x equals negative 2, x equals positive 2. So 2 vertical asymptotes. This is going to look neato. Okay, HA. Remember HA, you're looking at your degrees. So personally, of course, preferably you want to look at this version. Hopefully you could look at this and know that if you FOILed back out, you would get degree 2 because you'd have x squared, highest exponent on the variable would be squared, but you can always refer back to this if need be. So 2 and 2, my degrees match. So then I'm going to take numerator equals denominator. I'm going to take my lead coefficients. So in this case, 1 over 1, which is going to be 1, so my HA is 1. Okay, y-intercept. Remember, y-intercept is found by setting x equal to 0. So y equals on top. You could either use this version or this version again, okay? It's not like we had any holes, nothing canceled, so you could use either one. Let's just use this one, 0 minus 9, and then on this, 0 minus 4. So in other words, negative 9 over negative 4, which equals 9/4. So, 0 9/4. Okay, you would have gotten the same thing if you would have plugged in 0 in the factored version. All right, so now let's get busy with our graph. So for our graph, we have the roots negative 3, 0, positive 3, 0. We have VA at x equals negative 2, x equals positive 2. We have HA at y equals 1. All right, and then we have y-intercept at 9/4, so 2 1/4. So what you need to know now is that this point, of course, this curve, our curves are hugging our asymptotes. So here, this point is gonna, this curve is gonna hug these asymptotes. All right, this point here is going to be, this curve is going to look like this. More on this in a second, y. And then this curve, of course, will hug these two asymptotes. So, like I said, more on this. So this, if you have a situation where you have two vertical asymptotes like this, and a point inside, what's going to be in here is really dependent on this horizontal asymptote, because of course we can't touch or go through this, all right, at this point. So your graph here in the middle will always look parabola shape or cubic shape. Okay, if there wasn't a horizontal asymptote, then we might have like a cubic that hugs both asymptotes, the rightmost and the leftmost. But in this case, we can't go past this, so we know we're going to have our parabola shape where my graph can't go down, obviously, because then again, I would cut through this asymptote. So it's got to look like this, and arrows hugging, curves hugging asymptotes on either side. All right, so now number two. So numerator, not factorable. Okay, x squared plus 2. Now you could factor it with, you know, sum of squares, but it would be ugly. We're just going to leave it. Denominator, x minus 1, x plus 4. That's how that trinomial would factor. Okay, no holes, nothing cancels. So let's start filling out some information. Numerator equal to 0. So x squared plus 2 equals 0. So x squared equals negative 2. Of course, you're going to notice that this is imaginary because we have that negative under the radical, so that tells us no roots. Okay, VA, is next. Denominator equal to 0. So x minus 1 equals 0, as well as x plus 4 equals 0. So x equals 1, and x equals negative 4. Okay, HA, looking at our degrees. So the degrees match again. Numerator equals denominator. So leading coefficients, so 1 divided by 1, which would be 1. And then y-intercept, x equals 0. So we would have y equals, if I use this version, doesn't really matter again, 0 plus 2, which would be 2, and then 0, 0, and negative 4. So in other words, 0, comma, negative 1/2. Okay, start graphing away. X equals 1. X equals negative 4. No roots. That's why you notice I didn't graph anything there. HA, y equals 1. So that tells me I'm not going to have that cubic shape in the middle. I'm going to have a parabola shape. Okay, negative 1/2. All right, that tells me a lot right there too. Okay, so now here, I know a couple of things. So I know that in the middle, I'm going to have a parabola shape. It's obviously got to go down because a couple of things. I don't have roots, so I know I can't go anywhere near this axis or not too close. I can't touch it. So I know it's got to go down. These arrows have to hug the asymptotes. I know here what's going to happen is, again, I have no roots, so I can't have a graph on this side. Both of these graphs must be on this side, both of them. Because again, if I had curves over here, I would eventually have roots, and I don't. So since there's no roots, that tells me a lot. I could plug in to get those extra points, but you really don't need it if you're just wanting a basic shape, because again, the no roots thing really helps you a lot. All right. Last example, number 3. Number 3. Okay, we have an issue here because we don't have a single term. We don't have like one fraction. We can't have 3 plus this. So what we need to do is get a common denominator here. So we're going to multiply this 3 over 1 by x squared plus 3. And then x squared plus 3 and get a common denominator. So in other words, this is y equals 3x squared plus 9 plus 2 over that common denominator of x squared plus 3. So really, in other words, this is y equals 3x squared plus 11 over x squared plus 3. And then this cannot be factored. So this is what we're working with. Can't refer back to the original on this one. Okay, so this is what we're working with. Roots, numerator equal to 0. So 3x squared plus 11 equals 0. So 3x squared equals negative 11. Yes, you would want to divide by 3, but it doesn't really make much of a difference because you know when you square root, you're going to have an imaginary situation. So therefore, no roots, none roots. Okay, VA. Denominator equal to 0. So in other words, x squared plus 3 equals 0. Same situation where you have that negative under the radical. So we'll go ahead and just save some time. No VA. We're going to talk about what that means in a minute. And then last but not least, HA, based on the degrees. So the degrees are, sorry, you can't see that very well, can you? The degrees are equal. The numerator equals the denominator. Oh my gosh, I keep on doing that. Numerator equals denominator because the degrees match. So therefore, lead coefficients, 3 divided by 1. So y equals 3. All right, y-intercept is where x equals 0. If I can fit this all on here. So y equals 3, where I see x, I plug in 0, so actually you should know that's going to turn to 0, so 11 in the numerator over, that's going to become 3, so 11 thirds, 0, 11 thirds. Let's get to drawing. Okay, so no VA. No roots. Only have an HA at y equals 3. I have a y-intercept at 11 thirds. So 9 thirds would be 3. So this is 3 and 2 thirds. So 3 and 2 thirds. So what I was going to say earlier is when there's no vertical asymptotes, you're going to have a mountain-like shape. What I mean is you've obviously got to hug this asymptote, but you're not just going to be a straight line. You'll make like a hill or mountain. Okay, so that's what that looks like. And again, if you wanted more points to determine the height of the mountain and stuff like that and what happens along the way and when it starts smoothing out, then you can certainly do that. But for our case for today, this is enough.